Magandang umaga everyone. Magandang hapon everyone. Today's lesson is about sum or difference of cubes and factor and remainder theorem. Okay, let's begin with the bridge. If you did not bring your green paper with you, then use any lined paper and then just paste it or copy that on your green paper once we're back in our classroom. So, let's start. For each perfect cube, write an equation in the form of m raised to n equals n. Question number 1 has been done for you. So we got 8 here. So perfect cube means 3, which means you will be thinking of a number that when you multiply 3 times, the answer is that certain number. So if I have 2 here and 2 there and 2 there, 2 times 2 is 4 times 2 is 8. So that's why 2 raised to 3 is equal to 8. Got that? Let's have 64. So 64, if I'll think of a number that multiplies 3 times, that will give 64, the answer is 4. 4 times 4 is 16, times 4 is 64. So the answer will be 4 raised to 3 is equal to 64. Next, 125. 125, I would say 5, because 5 times 5 is 25, times 5 is 125. So you got 5 raised to 3 equals 125. Alright, next 1000. 1000 would be 10 times 10 times 10 will be 10 cubed is equal to 1000. Oops. I don't know what happened to this one. Alright. Next, 27. If I say 27, that would be 3. Times 3 is 9. Times 3 is 27. So that would be 3 cubed equals 27. 216. 216, I would say 6. 6 times 6 is 36. Times 6 is 216. So the answer is 6 cubed equals 216. Alright? Okay, let me erase everything so we can go next. Now, activity 1, I'm perfect. It's on page 230. It says, use the factor x minus 2 to write x cubed minus 8 as the product of two factors. So, given the polynomial x cubed minus 8, again, I need to think of 3 factors for each of these terms that will make a product of x cubed and 8. So this would be x and x and x. Oops. Well, this one is negative 2 times negative 2 times negative 2. So first set is x and negative 2. So I'll put x minus 2, which is based on the statement, we're using x minus 2 as one of the factor, which is, we got it here. The second factor will be, that would be x times x is x squared. Okay. And then you're multiplying whatever the digit in here. So you have negative 2 and x. So that would be plus 2x. And then negative 2 times negative 2 is positive 4. So that would be positive 4. If you want to double check if your answer is correct, so easy. You just need to multiply them back, one at a time. Okay? And then do this, do that, and do this. So let's begin. X times x squared is x cubed. X times 2x is 2x squared. X times 4 is 4x. X squared times negative 2x is negative 2x squared. Negative 2 times 4 is negative 4x. Negative 2 times 4 is negative 8. If you will do, here we go again. Hold on. Alright. If you're gonna do this will be cancels out. This will be cancels out. And what remain will be x cubed minus 8, which we are correct. Got that? Alright. Now, let's proceed to a rule pattern. It says here, write two polynomial expressions, one representing the sum of perfect cube, which is x cubed plus y cubed, and the other one is x cubed minus y cubed. So let me tell you about how are you going to represent a sum of perfect cube. This is the rule pattern. If you have x cubed plus y cubed, what you'll do is to make them separately as a binomial. Okay? Copy whatever the sign is. And then for the trinomial, you're gonna square the first term of your binomial. That's x squared. X times x. And then take the opposite sign of your binomial. So this would be minus. Again, this is positive. This is negative. Then multiply the first term and the second term, which makes x times y. And then it is always that the third term is positive. And then that is the square of the last term, which is y squared. So applying the rule pattern, now we have x cubed plus 8. So therefore, I'll make x plus 2, which patterns as x plus y. And then the trinomial will be square the first term, that's x squared. Take the opposite of the sign of your binomial, so I'll take this as minus. Multiply the first and the second term, and that would be 2x. And then square the last term, which is the 2, which makes 4. So that's the answer. For rule pattern for difference of perfect cube, it's the same pattern. It's just like you are in need of changing the sign into minus. So x and y, you're gonna change it into minus since this is minus, like plus and plus. And then to get the trinomial, square the first term, which is the x. That turns x squared. Opposite of the sign, if that's minus, this would be plus sign. Multiply the first and the second term, xy. And then always that the third term is positive, and then square y squared, that is y squared. Now applying the rule pattern, now you have x minus 3 4 3 is 7. To create the trinomial, square the first term, that is x squared. Multiply the first and the second term, which is the opposite sign of the binomial, so that would be 7x. And then square the last term, which is 49. That's it. If you want to put it back or check your answer, you may use Desmos and plug in both. Plug this in as one set and plug this in as one set as well, your factor. And if their graph or overlap, meaning your answers or our answer is correct. Alright, let's go next. Factor the sum and difference of cubes. Let's see if you will understand the rule pattern. X cubed plus 125. Which one do you think is the correct answer? I'll give you 30 seconds. Alright. Answer B. Second one. X cubed minus 64. Which one do you think is correct answer? 30 seconds. Alright. Answer A. X minus 4, x squared plus 4x plus 6. Next. Letter number 3. 8x cubed minus 27. 30 seconds. Alright. D. 2x minus 3. 4x squared plus 6x plus 9. I hope you all get it correctly. Good job. Now, activity 4, page 232. What's the remainder? Mai thinks that x plus 2 is a factor of x cubed minus 8. She started to use long division to find the second factor. What is the alternative way to solve Mai's problem? If you come and think about it, I think we solved that already. Let's go back. You see that? Wait, hold on. Back. X minus 2, x cubed minus 8, x minus 2, x cubed minus 8. Let's see if we got it right. Yep. Oh, this is x plus 2. Earlier we solved x minus 2. Alright. Now, what's the alternative way? So, the alternative way is we can use the rule pattern of x plus 2. Remember, the rule pattern would be x plus y times x squared minus xy plus y squared. Okay. If you use that, that would become x cubed minus 8. That is x minus 2, or plus 2, sorry. And then x squared minus 2x, and then plus 4. Alright. That's the alternative way. Instead of stressing yourself of doing this long division, another way to do that is through synthetic. Remember our topic for today? That is synthetic division. You may want to use synthetic division, and you should come out with the same answer like this. Alright? Okay. Let's go next. Now, check in. What is the remainder when 2x raised to 21 power minus x squared plus 4x minus 3 is divided by x plus 1? If we use the synthetic division, the remainder is, imagine that. So using the synthetic division, you're going to write all the numbers with an exponent. X squared, x, 19, da 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 da, until you reach constant. However, synthetic division is not always fun, as what I said. But it can always help you if your exponent is just as simple as less than 10. Now, imagine if you want to spend your entire 30 minutes just to write down all these terms, and then just find out that negative 10 would be the remainder. Now, let me tell you about this one. Same question, but there must be another way how to do this, an easiest way. The reason why Mrs. Capacia is your teacher is because I'm always finding the easiest way in solving those math equations. See? There must be a way. Alright, let's begin. Given the same problem earlier, which is, I lied, this is another one. Now, what I will show you is about the remainder theorem. What is a remainder theorem? When the polynomial f of x is divided by x minus a, the remainder will always be f of a. Probably you won't understand me unless we're going to have an example. For instance, your function x or function f is equal to 4x squared minus x minus 3. And then what is the remainder when f of x is divided by x minus 3? So x minus 3 is your factor. Now, to plug that in Desmos, imagine or open your tab and type in line 1 on the first tab. You're going to plug in the equation which is 4x squared minus x minus 3. Now, as a factor, you're going to write it as f of 3. Alright? F of 3 like that. Okay, here, like this. And then whatever the answer is here, for f of 3, that would be the remainder. Yes, this would be the remainder already. So the answer is 30. See how easy that is? Did you Do you need to write all of those terms? No. Did we use synthetic division? No. What did we use? Decimals. Alright? Okay, let's go next. Let's try this one. Oh, this is the 21. Okay, 21. Let's see. This is what we're expecting earlier, that we're gonna find negative 10 as well using another method. Let's see. I'm just going back. Okay. Now, using the method that we did, I'm gonna plug in 2x raised to 21 minus x squared plus 4x minus 3 with f of x. And then, it says the factor is x plus 1. So that would be f of negative 1. And look at what we got here. Minus 10. Which means that the remainder is negative 10. So whether we do synthetic division or decimals, we are still getting the same remainder. Question? Alright. Next, another one. If f of x is equal to 5x to the fifth plus 4x minus 3, then what is the remainder when f of x is divided by x minus 2? Same process. Line 1, you're going to plug in the equation. Line 2, you're going to plug in whatever the factor is, which is x minus 2. You're going to take the inverse of that. That turns positive. And then here's what the remainder is. 165. Alright. So easy. Okay. Next, what is factor theorem? So now that we master remainder theorem, let's move on to factor theorem. What is factor theorem? If the remainder of function p of x is divided by q of x, it is always 0. And then, that thing would be a factor of p of x. Well, you won't understand me unless we will make this possible. Ready? Okay. So, determine if function q is a factor of function p. So, this is what I meant. First thing, you're gonna plug that in. Oh, this is decimals. This is synthetic division. You see how we got 0 here? Which is correct. Okay? So, once your remainder turns to 0, then you can say that x plus 4 will be a factor of this equation. Okay? Let's do that. Alright? X plus 4 is a factor because the remainder is 0. Yes, that is correct. Okay? Again, this is using synthetic division. Alright. I'll show you how not to use synthetic, but instead, you'll just need to use the trick of decimals. So, plug this in. Plug in the equation in line 1. Okay, again, hold on. Line 1. It says, which of the following is a factor of f of x? Now, among these choices, if I'm taking the EOC, what will I do is to plug this in decimals. So, line 1 will be x cubed minus x squared minus 17x and then minus 15. Now, after line 1, this would be your line 2. What you will type in line 2 would be f of 3. Next is line 3. Next is line 4. And lastly would be line 5, which is not possible for me to write. I don't know why. There you go. Alright, let's see. If I plug in f of 1, f of 2, look at f negative 1. So the answer will be x plus 1. It is only x plus 1 got a 0 as their remainder. Make sense? So this is what the factor theorem means. Okay, let's do some examples. Alright. It says, which of the following is not, meaning one of these options will give you a remainder and not 0. Let's begin. Plug this one in decimals. F of x equals x cubed minus 4x squared minus 15x plus 18. And then the option, f of negative 6, f of 6, f of 1, f of negative 3. You see that? So, the answer will be f x plus 6 because it's not a factor. Alright? Okay. Now, actually, we are done. What I want you to do, if you click this one, if you click that, you will get directed into student decimals. Okay. Remainder and factor theorem. If you're done with this one, then you'll have an attendance for Wednesday, February 19. Bye you all. See you when we see you. Bye-bye.